There are certain applications that produce a massive number of events from almost as many sources. We often refer to this as big data. If you're wondering what is big data is data that contains greater variety, arriving in increasing volumes with more velocity data. Or we also call these three V's: variety, volume, and velocity. Big data comes from myriad sources. Some examples are transaction processing systems, customer databases, documents, emails, medical records, clickstream logs, mobile apps, social network, and many more. Big data can require extensive infrastructure for this need. Now you could see number of events generating by such applications require something which could process millions of events per second. So this is the time where I would say hello and welcome to the Design and Event Hub messaging solution. And yes, Event Hub can receive and process millions of events per second. Data sent to an event hub can be transformed in real time or stored for later analysis. So let's quickly check Event Hub. What is Event Hub? Well, Event Hub is a big data streaming service or platform with low latency and seamless integration with data and analytics services inside and outside Azure to build your complete big data pipeline. It can receive and process millions of events per second, and it is fully managed service, a PaaS service, which means you can focus on your business solution rather than managing and configuring your clusters. It supports both scenarios, real-time and batch processing. The best part is we can capture data in real time in an Azure Blob Storage or Azure Data Lake for long-term retention or batch processing. We can achieve this behavior on the same stream that we use for driving real-time analytics. And that is something very interesting. It is highly scalable. We can start with data streams in megabytes and grow to gigabytes or terabytes. It supports industry standard protocols like AMQP, Advanced Messaging Queuing Protocol, HTTPS, and Apache Kafka. Also, various languages like .NET, Java, Python, JavaScript, along with the seamless integration with Azure services like Stream Analytics or Azure Functions. Event Hub comes with the basic, standard, premium, and dedicated pricing tiers. You could easily compare this with the Azure App Service plans, like basic and standard are on shared resource model, premium is isolated, and dedicated is a dedicated resource model. Now we know what Event Hub is. It's a good understanding as of now. Let's quickly check the base architecture of any eventing model. So Event Hub represents the front door for an event pipeline, often called an event ingester in solution architectures. An event ingester is a component or service that sits between event producer and event consumer, as you can see in the base architecture right here, which means multiple events per second would be produced by the event producer and sent to the event hub, which will ingest the streaming data to the consumers. Let's see what all could be an event producers, right? So it's a type of client that serves as a source of telemetry data, diagnostics information, usage logs or other log data, or a mobile device application or a website. In a nutshell, it's the event producer. And if we talk about an event hub consumer, it's a type of client which reads information from the event hub and allow processing. It's very simple. But if we go inside the event hub and check the detailed architecture, that will be very interesting and give us the exposure how actually event hub works, because event hubs cannot be created without an event hub namespace. An event hub's namespace act as a container and can host multiple event hubs, just like storage account, and then we have containers, and then we have blob in the same way. So Event Hub supports the concept of partitioning, as you can see, partitioning, which is like a partition the data into multiple smaller data stores. Same concept, which are uniquely identified with the partition key. Partitions also help in bringing parallelism and concurrency for applications reading the events. For example, if there are 10 partitions and 10 parallel readers can read the events without any degradation in the performance. Now, data has reached into the partition, as you can see in the detailed architecture. Now, data needs to be consumed by the consumers or receivers as per the design, which I borrowed from MS documentation, of course. Well, consumers are applications that read events from Event Hub, but they can't directly consume from partition. So they need something called consumer groups. So consumer groups are created for consumers to connect to in order to read the events. There can be multiple consumer groups for an Event Hub, and each consumer group has access to all the partitions within an Event Hub. Now I'm pretty sure we have a decent understanding of Event Hub, what it does, what it is, what is the architecture, how the application looks, and how consumer consumes the data. Now it's time to check out few use cases. There we go. There are so many. So we can use this Event Hub for the architecture or help during anomaly detection, making product recommendation to online customers in real-time analytics, monitoring pipelines and distribution systems by oil companies or maybe nuclear plants, generating predictive maintenance schedules. Like that's what the Microsoft does for their hardware. Trigger specific actions when certain thresholds are identified, which is very common use case. Analyze real-time telemetry streams, which could help us to know intrusions, security breaches, failure of component, and many more. So now we know the use cases as well. Now they are something that we should be aware of. Let's conclude this session by talking about considerations whenever we think for Event Hub, whenever we're selecting Event Hub. So there are some consideration that I have picked to conclude this session. The very first is expect language and framework integration. We can send and receive events in many different languages. Messages can also be received from event hubs using Apache Storm. Choosing a right pricing tier and throughput, of course. Scaling of event hubs is controlled by how many throughput units or processing units you purchase, just like any other unit that Microsoft says, like DTU or data warehouse unit. Similarly, here we have throughput or TU, throughput units. Other performance aspects depend on the pricing tier chosen, like basic, standard, premium, and dedicated. Let's take a quick glance on the throughput, which is also very important. Throughput can also be configured at the namespace level. As I said, first namespace and then event hub. Namespaces are containers that consist of multiple event hubs in the same subscription and region. The throughput is calculated as throughput units, TU. And each throughput unit provides ingress up to 1 MB per second or 1,000 events per second, whichever comes first, and egress up to 2 MB per second or 4096 events per second. Remember, Event Hub uses a pull model. The pull model used by Event Hubs differentiates it from other messaging services such as Azure Service Bus queues. Pull model means that Event Hub simply holds the message in its cache and allows it to be read. When a message is read from Event Hubs, it isn't deleted. The message remains for the consumers. Account for data failures. Yes, there is no built-in mechanism to handle messages that aren't processed as you expect them. For example, imagine your consumer malfunctions because of data format. Event hubs won't detect this issue. The message remains until its time to live, TTL, has expired. Now, last but not the least, process the data stream. Events received by event hubs are added to the end of its data stream. This data stream orders events by the time they are received. Yes, There is a timestamp, and consumers can seek along this stream using time offsets, temporal data. Well, this is all about designing an Event Hub messaging solution. We went through a lot of Event Hub, and